This is CSIR NET question paper. Here we talk about the interference. In this question, a pair of parallel glass plates separated by a distance d. This is the pair of parallel glass plates separated by a distance d, illuminated by white light as shown in figure. Also shown in the graph, intensity of the reflected light as a function over wavelength. This is the intensity of the reflected light and as a function over wavelength. Assuming that the interference takes place only between light reflected by the bottom of the surface of the top plate and the top surface of the bottom plate. So, the condition for the interference takes place when we know the condition for the interference takes place when this 2 mu d is equals to n lambda, where mu is the refractive index and d is the distance between the parallel plates, where d is the distance between the parallel plates and mu is the refractive index. Mu is refractive index. So this interference takes place when this condition is satisfied. 2 mu d is equals to n lambda. Now from figure at A we can write lambda 1 is equals to 500 and at B lambda 2 is equals to 510. So for A 2 mu d is equals to n lambda 1, and for B we have this 2 mu d is equals to n plus 1 lambda 2. So n equals to here 2 mu d divided by lambda 2 minus 1. These are the two equations. This is the equation number 1 and this is the equation number 2. So here putting equation 2 into 1 is 2 mu d divided by lambda 2 minus 1 is equals to 2 mu d divided by lambda 1. For air, we know this refractive index mu is equals to 1. So d equals to half of lambda 1 lambda 2 divided by lambda 1 minus lambda 2. This equals to half of 500 into 510 divided by 500 minus 510. This is lambda 2. So this equals to minus of 12,750 nanometer. So D is nearly equals to 12 micrometer. Here this n means 0, 1, not 0, this is 1, 2, 3. Here this n is 1, 2, 3. So as this point B, here for point A, this 2 mu D is equals to n lambda 1. As for point B, this is the lambda 2 is the another point. So here we can write this is n plus 1. This is the another point from n. So we can write this 2 mu D is equals to n plus 1 into lambda 2. So we can write this equation 2 in this equation 1. So from this, D can be calculated as the distance D is closest to 12 micrometer. Is the answer option A. The answer option is A. A is the correct option for this question. So if you have any query, you can comment in the comment section, and you can WhatsApp us in this number 98367 93076. We can WhatsApp us in this number 98367 93076 for any query. So that's all for today.